In the next video in our forces unit, we'll be looking at Newton's second law of motion. We have two learning targets for this lesson, and you can see the first one is simply to state Newton's second law of motion. So Newton's second law of motion, it is the quantitative aspect of how force and motion are related. The word quantitative simply means how the numbers work, or what is the numerical relationship between force and motion. So as you might expect, if we have a numerical relationship, Newton's second law is best stated with an equation. And Newton's second law is simply this: the net force acting on an object is equal to the mass of the object times its acceleration. We could write that same equation using some symbols, where net force equals mass times acceleration, using the same symbols that we have already used. Notice capital F here for force, and then the subscript net, and that's equal to m times a for mass times acceleration. As an equation helper, this would look like so, and as always, you do not need to memorize this. You will always have that on a quiz or some other assessment that you need, but that is what Newton's second law would look like. Alright, so we've looked at Newton's second law. We know that it's mass times acceleration equals net force. What we want to be able to do now is use that in calculations. So the next thing I have here are just a couple of examples that involve using Newton's second law as a calculation. Alright, so notice up here in the right hand corner, I give you the equation helper there for Newton's second law for your reference. So I want you to consider the box below that is being pulled by a rope. So here's the box, and you see we're given a mass of 25 kilograms to the box, and it's on some sort of surface, and then there's a rope attached to it that's pulling it to the right. Let's say the pull force pulling it to the right is 175 newtons, while the friction force acting on the box is 100 newtons. And again, notice that the friction force has to be negative because we've defined the right as being positive for the pull force. So the negative 100 newtons for the friction. First question, determine the horizontal net force acting on the box. Do note that there would also be vertical forces going up and down acting on the box, but for this problem we're just not concerned about those. We'll only consider the horizontal ones. So horizontally, I know that I just need to add the forces up. So the net force acting in the horizontal direction is 175 newtons, plus the negative 100 newtons, or minus 100 newtons, and that's going to equal 75 newtons. So there's our net force in the horizontal direction. Next question, determine the horizontal acceleration of the box, or in other words, determine the acceleration of the box in the horizontal direction. That would be the same thing. Well, you might be wondering, how would I know the acceleration? I don't know its velocity, I don't know the time. Well, remember, Newton's second law relates acceleration to something other than velocity and time. It relates acceleration to net force and mass. So if I look at my equation helper here, I can see acceleration would equal the net force acting on the box divided by its mass. So there's my equation. Acceleration equals net force over mass. Notice we just calculated the net force acting on the box, and we're given the mass of the box is 25 kilograms. So my acceleration would be calculated by 75 newtons divided by 25 kilograms. Now before we worry about getting an answer here, I want to ask you a question. How do these units work? Newtons divided by kilograms. How am I going to get a unit of acceleration out of that? Well, you probably don't know the answer to that because you aren't very experienced with this unit Newton, but I'll tell you this. 1 Newton, that unit, Newton, is equal to a kilogram times a meter per second per second. So instead of writing newtons here for the unit, I could write this, the kilogram meter per second per second. So if I do that, if I just look at my units, I notice I have newtons divided by kilograms. So newtons divided by kilograms, that equals the kilogram times meters per second for the Newton, divided by kilograms. Now ask yourself, do any of those units cancel? If you look at that, you'll see, well, of course they do. Kilograms appears in both the numerator and the denominator, so the kilograms cancel. What are we left with? Well, a Newton divided by a kilogram is a meter per second. And you will recall that the meter per second, is a unit for acceleration. So my answer here, 75 divided by 25, that is 3, and my unit is meters per second, which is a perfectly good unit for acceleration. Now I still have one more question here for this particular problem. This is question C. In what direction is the box accelerating, and how do you know? Well, a couple things you can think about here. First of all, you can just look at the forces acting on the box. You'll notice there is more force pulling the box to the right than to the left, so that might indicate the direction the box is accelerating. Also recall from the previous slide that we found that the net force was positive, and we see here that positive we have defined as being towards the right because our pull force we said was a positive 175 newtons. So considering those two things, we can say that the box is accelerating to the right. And we know this because the net force is pushing the box that way, or pulling the box that way, whatever you want to say. Alright, so there's the first problem. Second one's a little more difficult. Maybe not at first, but the last question is a little bit more difficult than what we saw there. So here's the problem. At one point during a dive, a 75 kilogram skydiver is accelerating at a rate of 6.5 meters per second before the parachute opens. Question A. Determine the net force acting on the skydiver at this time. Now again, you might be considering, well, I don't know any of the forces acting on the skydiver. How could I find the skydiver's net force? Well, I don't need to, because we're given mass and acceleration data, which we can relate using Newton's second law. Using Newton's second law, I know that the net force acting on the skydiver must equal the skydiver's mass times the diver's acceleration, which we're given both of those values. So the mass of the skydiver is 75 kilograms times the acceleration of 6.5 meters per second. And I want you to think about the units there for a second. What unit will we get for our answer? If you consider the previous slide, you'll remember that a Newton we said was the same thing as a kilogram times a meter per second. And that's exactly what we're going to have here. So our unit here will be the Newton. So 75 times 6.5 is 487.5, and our unit is the Newton. So the net force acting on the skydiver is 487.5 newtons. Question B. What direction is the net force in? Or we could also ask the same question by asking, what direction is the skydiver accelerating? Now, there's no information here given to us as far as what exact forces are acting on the diver. However, if we just use some common sense, we can probably figure this out fairly easily. Notice we're told that this acceleration is occurring before the parachute opens. So if you're a skydiver and you're diving out of an airplane and your parachute hasn't opened, think about what direction would you be accelerating. Well, I think most of us would fairly easily agree that common sense would tell us that the skydiver would be accelerating downwards or towards the earth before that parachute opens. So this net force then is directed downwards. Now that is important here for our next question. Next question being, suppose 750 newtons of gravity act on the skydiver. How much air resistance is opposing the diver's motion at this time? So what we're asked about is we're asked to specifically find a particular force, in this case the air resistance. So here's our skydiver. Now we're told that 750 newtons of gravity act on the skydiver. Ask yourself, what direction will that gravitational force be in? Well, we're all familiar with the Earth and how it works and the physics behind it, and we know that gravity pulls us down towards the middle of the Earth. So the force of gravity, and take a look at how that's notated here, capital F for force, G subscript there for gravity, that's 750 newtons. And do notice that I've called that a positive 750 newtons. Now ask yourself, what direction will that air resistance force acting in opposing the motion? Well, the diver's going downwards, so the air resistance would be upwards then. And that would be a friction force. So I've labeled it as such. And then I want to know what that is, so I'm putting question marks there. Now at first this might seem pretty ridiculously hard, but it's actually not too terribly bad. Because recall from the last slide, we calculated the net force acting on the diver. We found that the net force acting on the diver was 487.5 newtons, and we said that that net force was directed downwards. And do notice here that we've called that a positive, and that matches our positive gravitational force pulling the skydiver downwards. Well, I know that a net force is just the sum of all the forces acting on an object in a particular direction. Now in this case, I'm talking about the vertical direction, up and down, so that net force has to be equal to the gravitational force plus the friction force. So if I plug in the numbers I know the net force is 487.5 newtons. That has to be equal to the gravitational force of 750 newtons plus that frictional force. So if you ask yourself, how am I going to find this frictional force, just consider this. I know that 750 plus whatever the frictional force is has to equal 487.5 newtons. So that would be the difference between the two then. The friction force simply must be the difference between the net force and the gravitational force. So the 487.5 newtons minus the 750 newtons, that gives me a negative 262.5 newtons. Now ask yourself, does it make sense that the frictional force is negative? The answer to that question is yes, it does make sense. And if you're not sure why, that's because in our problem here we have defined down as being positive. Why do we define it that way? It really doesn't matter. There is no reason for it. We could have just as easily defined down to be negative, but we chose to define down as being positive. So the frictional force pushing it up then must be negative. So the fact that it's negative does make sense here. So to answer the question, the frictional force or the air resistance force opposing the diver's motion is 262.5 newtons. In this case, in the upward direction. I know that because it's negative, and that is the direction that we defined as being negative. All right. This concludes the video here on Newton's second law of motion. I know there were just a couple of short examples there. You will get plenty more practice on Newton's second law with different problems you'll be working in class.